Today I want to talk about how to add and subtract these rational expressions, these fractions that have x's maybe in the top and bottom, and we have to add them up. So let's recall how we add fractions when it's just plain old numbers. Remember, you need a common denominator. You have to have a common denominator. So if you have 2/3 plus 7 more, you have a total of 9/3. And of course, at the end, sometimes you can reduce, right? 9 is 3 times 3, so this 3 cancels the 3 on the top, so you're left with 3. Or, of course, you could just think about 9 divided by 3 is 3, but I'd love for you to see how, or recognize how, the factors are canceling, because sometimes down here we may need to cancel factors at the end, because this works just the same for rational expressions. When we have a common denominator, it could not be easier. So let's zoom in here to these questions. So check this out. This already has a common denominator. They're both x's. So we're going to go ahead and add them up. And we get x squared plus 3 all over what? Do we get 2x? No, remember the denominator stays the same. Let me zoom back up here. Do you remember when we added the thirds? What did we get? We got thirds. So down here, when you add fractions that have an x in the denominator, you're still going to have a plain old x in the denominator. And this is fully simplified because the top is not divisible by x. All the terms aren't. The 3 doesn't have an x, so that is the answer. Okay, over here, x squared minus 9. Do you notice how the denominators are already the same? We're good to go. We get x squared minus 9 on the top, all over the denominator, which would be x minus 3. Now, this should look familiar. This is called a difference of squares. Difference of squares, and that will factor. So let's go ahead and do that. That would be x plus 3, x minus 3, all over x minus 3. Oh my goodness, look at that. They have an x minus 3 factor so that it cancels. So the final answer in this question would be x plus 3. X plus 3. Okay, let's zoom out here and go back over to the left. Again, this time we have a minus sign, folks, and a binomial here. So we will have to distribute that like we did earlier in the year when we were working with polynomials. So I'll go ahead and show lots of work here. We get x plus 3 minus the quantity 5x minus 17 all over 12. So that is x plus 3 minus 5x plus 17 all over 12, which is negative 4x plus 20 all over 12. And what do you know? That can simplify further. You see how we have 3 things here, and they're all divisible by the same number. So I think what I want to do is factor out whatever I can on the top here. Sure, looks like I can factor out a 4. And that leaves me negative x plus 5 all over 12. So then, just like you did in the last section here, this reduces to 1 to 3 because 4 goes into 12 3 times. So the final answer would be negative x plus 5 over 3, or if you want to rewrite it, 5 minus x over 3. Either of those would be absolutely fabulous. All right, one more example here, and I think this will have some reducing at the end. So let's see this. We're going to have to distribute the minus sign. I guess I should also say, do you notice how the denominators are the same? Sorry for the horrible resolution here, but you see the denominators are the same. So we get x squared minus 6x, but it becomes plus 9 when you distribute that minus sign, all over x squared minus 9. So I'm going to go ahead and factor that right now while I'm at it, because the top is x minus 3 times itself. It's x minus 3, the quantity squared. So let me keep writing here as quickly as I can. We cancel those out. The final answer is x minus 3 over x plus 3. So we will still be doing lots of factoring in this section. So that's when you have a common denominator. Not too bad, right? Common denominator. Well, folks, what happens when you do not have a common denominator? How do we do this? Well, let's recall what we did when we had fractions, when we just had numbers. How did we do this? We had to, what I like to call, upgrade both fractions to have the common denominator. So you have to decide what it would be what is the first multiple that these two have in common? And it's just a 6. So what I'm going to do is multiply the left fraction by the number 1, 2 divided by 2, and that will change it to be sixths. It's kind of like getting the pizza cutter out and you're slicing it up differently so that all the pieces are the same size. We now have 11 over 6. 11 over 6 would be the answer there. And over here I've got another example. What would be the least common denominator here between 7 and 8? I think it would be 56. That's the best we can do. So this will need an 8 introduced to upgrade it, whereas the second fraction would get multiplied by 7 over 7. So we end up with 72 over, all over 56, by the way, all over the common denominator, minus 70. So that's 2 over 56, which is 1 over 28. And that's how you did it with numbers. Now, how on earth are we going to do this with unlike denominators? So I'm trying to break this down into steps a bit for you. What you want to do is factor everything, especially the denominator. Okay. Then you introduce all factors to each fraction so they match. You'll see what I mean here in a second. Add or subtract fractions, and then simplify by factoring again. You might have to factor it some more again. So lots of factoring in this particular chapter. Now, there's not a lot of factoring to do here because this doesn't have, binomials or trinomials going on, so not a lot of factoring to do. So take a look at the denominator. These are the denominators. How could we make them match? How could we make them match? If only what? If only the second fraction had a y, right? If only the second fraction had a y, they would match. So let's go ahead and upgrade it. We introduce the missing factor. This is what I mean by introducing the missing factors to all the fractions. So this one the one on the right needs a y. Now they match and you can add them up. So you get 2y plus 5 all over x squared y. And that cannot reduce. Those y's do not cancel because the 5 doesn't have a y. All right, how about this question over here? This one's a slightly more complicated. So what would the least common denominator be here? Well, I think the number 6. Do you see how the fraction on the left has 2 a's, whereas this one only has 1? So I think we're going to have to upgrade them both to have 2 factors of a squared. And then the fraction on the right has 3 factors of b, whereas the one on the left only has 2. So I think we'll have to upgrade them all to have 3. So let's introduce the missing factor. So the one on the left needs to be upgraded to 6, and it also needs another factor of b. So this needs 2b on the top also. And the second fraction, remember we said it was missing a factor of a there. It needs another one. So we're going to multiply by a over a, and I think that will get them to be the same. So on the top here, this is 14b minus, what do we have here? 2a. So let's move over here. We have 14b minus 2a all over the common denominator, which is 6a squared b to the third, common denominator. Now I do see that there's a little bit of reducing we can do because these numbers are all even numbers. So I can go ahead and factor a 2 out of the top, which would leave me with 7b minus a all over 6a squared b to the third. And then 2 goes into 6 3 times. So the answer would be 7b minus a all over 3a squared b to the third. Okay? All right, so let's move to where we have some binomials and trinomials in the action. You see how these denominators look very different, don't they? Well, the first step I said was to factor everything first. Factor first, folks. Write that in your notes. Factor first. So the bottom on this left fraction is going to be x plus 7, x minus 7. Now, factoring this, you can't reverse FOIL this, but there is a greatest common factor. So there's a 2 there. And then that leaves behind x plus 7. And then on the top is still 3x. So we factored first. So we did that. Now let's move to the second step, and that is to decide the least common denominator. What would it be here? Well, I see an x plus 7 on both of them already, so that's going to be part of our least common denominator, right? Now, this guy has a 2, and this doesn't. So we are going to have to use a 2 as part of our least common denominator. And then this fraction has an x minus 7, and this one doesn't. So we will have to introduce that and make sure that both fractions have an x minus 7. So we're going to upgrade both fractions to match. So this fraction needs a 2. Remember we said it was missing the 2, whereas this one needs an x minus 7. That's the way I think about this, just introducing and upgrading each fraction so they all match. All right, so now we can go ahead and get 4 plus, I'm going to go ahead and do the distributive property here while I'm at it. This is 3x squared minus 21x all over the common denominator. And I'm not going to bother foiling this out, and the reason is because factored form is more useful anyway. So we want to just keep it in that factored form. All right, so I'm going to rewrite the top as 21x plus 4 all over. Hopefully I don't make any small silly mistakes as I'm trying to go quickly here for you. And you know what? This top cannot factor. It can't factor. So we are done. This would be our answer. Nothing is going to cancel here. All right, moving on to this next one. What do we do first? We factor specifically the denominator, because denominators first. That's the first thing you do. So x plus 10 over 3 times the quantity x minus 5, that's called a greatest common factor, minus 3x plus 15, no change there. But on the denominator, we get 6 times the quantity x minus 5. Oh my goodness, look at that. They're actually pretty similar. They both have an x minus 5 already, but this one has a 6, this only has a 3. So what do we do? What do we do? What do we do? We multiply the first fraction by 2 over 2 to upgrade it. Now don't forget, we will have to distribute here on the next step. So let's do that. We get 2x plus 20 minus, now don't forget, there's invisible parentheses around there, so we have to subtract the quantity 3x plus 15 all over the common denominator. Let's leave that in factored form, because we may have something that cancels here at the end. Let's see. So now we go ahead and distribute minus 3x. That would be negative x. And then minus 15. That's plus 5. All over ours. Again, I'm not going to multiply this out, because look what happens on the top. We could factor out a negative 1 on the top. And we have a matching factor that was hiding in there. The final answer has no x's in it. It has absolutely no x's. And what that means is in this question, the x's were actually irrelevant. Anything you plug into this, x equals 1, 2, 3, a million, you should get negative 1/6 as your answer. That's what that means. All right, there's quite a few here, and I know this is tough, but we got to go through lots of examples so you can see how this works. All right, what is the common denominator here? Well, we don't know until we factor. Factor first, folks. That's really important. Factor first. Can't say that enough. So this is a minus 5 all over a plus 3, a plus 1, plus a minus 2 all over a plus 1 and a minus 1. That's called a difference of squares, as you've seen before. So let's see what's floating around. I see an a plus 3, but this one doesn't have it, so we'll have to put it over there. This one already has an a plus 1, and we got an a minus 1, so we'll have to introduce that one over here. So let me grab another color. We'll do a minus 1 over here, a minus 1 over here. And then what did we say this one needed? A plus 3, a plus 3. So now we do have to FOIL or box method these guys out so that we can combine like terms. So here we go. We get a squared minus 6a plus 5 plus a squared plus a minus 6 all over the common denominator. I'm not going to multiply this out. I'm leaving it in factored form. 2a squared minus 5a minus 1 all over the common denominator. Again, don't bother multiplying this out. And we get our final answer here because, you know what, I tried earlier to factor this and it does not factor. So that means there's nothing that can cancel, and that's just our answer. Okay, let's go over here. This one looks pretty easy, doesn't it? And it is. It's not bad. So we have n plus 2 on the bottom. This one needs it, right? We have n minus 1. This one's going to need it. So let's go ahead and upgrade our fractions. And let's put parentheses around everything. So this needs an n plus 2, but so does the top then. This needs an n minus 1, so does the bottom. All right, so now we go ahead and FOIL, we subtract, and we FOIL over here. Don't forget about that subtracting in the parenthesis. So we get n squared minus 1 minus, here's my parenthesis, n squared minus n minus 6 all over n minus 1, n plus 2. And then if we distribute the minus sign on everything, the n squares end up canceling. And you get n, and it'll become plus 6. So n plus 5 all over n minus 1, n plus 2. And you can go ahead and circle that. That's the answer there. All right, so that is how you add rational expressions. I've got a couple problems here for you to try, so I'd love for you to pause the video at this moment and give those a try, and then we'll see how you did, okay? So pause it, 3, 2, 1, pause. Okay, here we go. Let's go see how you did on this. So the denominators are already the same, folks, so we just add up the numerators. 6x plus 1 over 2x plus 1. If you write 4x plus 2 on the bottom, oh my goodness, you do not want to add the denominators, right? Denominator stays the same. On the second question, what is the first thing you always do? Factor. So this is x plus 3. This is x plus 1. Don't bother factoring the top because we're just going to distribute the minus sign on those 3 terms anyway, so you want to just leave it nicely multiplied out. So it sure looks like we need to introduce x plus 1 on the left-hand fraction here, x plus 1, and go ahead and then FOIL this out. So this would be x squared minus x minus 2 minus the quantity, x squared plus 3x minus 1, that just comes from, you know, on that second fraction, all over x plus 3, x plus 1. So this x squared cancels this one because we distribute the minus sign. If you distribute the minus sign there, you get negative 3x. So we will get negative 4x. And then if you distribute the minus sign there, you get plus 1. Combine it with this negative 2 there, and you get minus 1 all over x plus 3, x plus 1. Leave it in factored form. And that does not reduce. You can factor out a minus sign, but it doesn't really do anything for you. All right, so in this video, hopefully you can now say that you can add and subtract rational expressions with common denominators. that you can find those least common denominators and then add them. And then at the end, just like before, you can simplify these fractions, even complex fractions where you have a fraction inside a fraction. You've seen some of those throughout this chapter. All right, hopefully this was helpful, and until next time.